Here we go. All right, so we're going to be looking at area of a circle. And if you remember, hopefully you remember that the area of an entire circle is pi r squared. Okay, so when we are looking at a sector of a circle, in real life, I always think about like pizza is normally cut into slices. And, you know, if I just cut one little slice of pizza, this is what we consider a sector. It's bounded by two radii, right? The radius and another radius. It's not, so this is a sector that we can find the area of. We cannot find the area of that sector. That does not work. Okay, so we aren't going to learn how to do this just in geometry, but we can find this. So notice if you think like piece of pizza, piece of pie, we can find this as long as it's bounded by two radii or a radius and another radius, whereas this is not bound by, these are just two chords, okay? And it's very similar to our arc length in the fact that, you know, we know a whole circle is 360 degrees. We can find the area of an entire circle if we know the radius. And so when we're looking at this, the area of our sector is going to be in proportion with the arc measure of that sector over 360 degrees. So this time it still is part over the whole equals part over the whole. And then we kind of cross multiply as necessary. Okay, so looking at some examples, you have this shaded area. We see that this has a central angle of 160 degrees. So I know that this arc PR also has an arc measure of 160 degrees. And I have a tendency to always just kind of start with, even though I know it says area here first, I have a tendency to start with my angle. It does not matter the order that we're doing this, one left to right. It does matter numerator and denominator and making sure that we're talking about angles with angles and areas with areas. So here's my 160 degrees for this shaded sector that we are looking for. And I know that there's 360 degrees total. So this is telling me essentially a ratio of how much of the whole circle we are talking about. 160 out of 360, right? Now, the area, which I'm going to just, in this formula, I'm going to leave in terms of pi, and then we can always use the calculator to find an approximate answer as well, a decimal answer. So my area is pi r squared. If I look at this one, since it looks like they have just given us a radius, this is pi times 10 squared, so my area is 100 pi. I usually find my area off to the side, at least in terms of pi. I probably don't want to put it as a decimal because it's going to be never ending. So I don't want to just kind of round and then round. And we're looking for the sector area. So I'm just going to put area of, what is this? Sector PQR. Okay. It's not an angle, but it is that sector area, PQR. And so now when we're looking at this, I'm just going to cross multiply. And so it's 160 degrees times 100 pi divided by 360. And that's going to be my area. I'm just going to put that down. This says area of PQR. Yeah, just this shaded area. Or if you put sector area, or if you use X, just something that you're going to recognize that what you're talking about in this one. Okay, if I want to leave this in terms of pi, if they ask for an exact answer, I would just in my calculator type in the numbers only, let my calculator do the work. So 160 times 100, right? Divide that by 360. I get this crazy decimal. So do you guys remember what we would hit to change that decimal into a fraction? Math button, good. And then I hit the fraction and I hit enter again. And it's 400 over 9. Ugh, crazy answer. Okay, so 400 over 9. And we can't forget that it's in terms of pi with our exact answer. Now, because it was radius squared, that's inches times inches. So area always has is going to be a square for our unit. What I do find probably more often than not is that we use a decimal answer. A lot of times with area, they don't ask you for the exact answer. A lot of times with area, for some reason, they'll ask you for a decimal. So if I wanted to put this in and just use my pi symbol, sometimes I use the pi symbol. Sometimes they'll tell you to use like 3.14, or they tell you what to use for your pi in terms of pi. So you looking at this, I'm just going to take my answer, and I know I need to multiply it by pi. And I get 139.6. I'm going to round it to 2 decimal places. So since it's 0.626, I'm going to round that up, and we'll say inches squared. Okay, so just being familiar with both of these methods. Now, when I'm looking at this next one, we're looking for this shaded area again. Okay. And sometimes they're really nice and they give you the shaded area angle. They tell you what it is. If I were looking for any ideas on how, if I wanted to find the unshaded area, what I could do, what could I use for an angle if I wanted the unshaded area? Right? What if this was taken out? Yeah, subtract what's taken out. Like, so if we wanted, if they don't give you the angle that you're looking for, that you need, you can subtract it from 360 or maybe 180 if they've given you a diameter. So be aware that you might have to do some work to get that angle. Like this might be 110. If I wanted to find the shaded area for the unshaded portion, I would just do 360 minus 110. Okay, so something to keep in mind for future reference. So this is 110 degrees. So that means that this arc is 110 degrees. That's forming my sector. And my radius, they gave me my radius. Be careful if they give you a diameter, because our radius is what we need for that formula pi r squared. Okay, it's not like the circumference where you can use a radius or a diameter and still get the same, use a different formula. We need to find the radius so we can square it. So 21 squared is 441. So I know my area of my whole circle is 441 pi. If I want to find what this portion of is it, I need to look and say, and I'll set it up a little bit different. We're looking for our sector area. There's not a fancy variable I could use right now. So I need to know part over the whole. So the whole thing is 360 degrees. The shaded area that we want is 110 of that 360. So that kind of tells us that we have to keep these ratios the same. And so I'm going to go ahead and multiply out 110 by 441 pi. And I'm going to divide by 360. Now, for my exact answer, I don't want to type in the pi. So I would do 110 times 441, divide by 360. I get a crazy decimal, right? So I'm going to, since I wanted this an exact answer, this one actually terminates. So I guess it's not as crazy as some of ours. But if I turn this into a fraction, I get 539 divided by 4 pi. Okay. So there's my exact answer. If I like the decimal answer, which for area I kind of prefer, I'm going to take that and actually multiply the pi in. And it's 423.33. And, I forgot my little thing, my units. This is millimeters squared. All these things that we need to do. Okay. So arc length and sector area use very similar concepts, and you should be familiar with, how to find the area of a circle and how to find the circumference of a circle. Okay. In examples 7 and 8, it's slightly different. In examples 7, 8, they've told you this is the area of the sector. Okay. So they've told you what the area is, and they've also told you what the arc measure is by giving you that central angle. And so we're going to set up this problem, but we're trying to find the total area of the circle. Okay, so let's write this up. Remember, it's part over the whole. So I'm going to start with the part that they gave me, sector area. That part was 123.45. Over the whole area of my circle, that's what I'm looking for. I do area with the little circle symbol so I can kind of keep it straight. I sometimes, if I do sector area, I might draw, well, that looks like a triangle, but I tried to draw a little pie piece, but it doesn't work as well. Now, we know that the whole circle has 360 degrees. What's my arc measure here in degrees? 70. Okay. Now, so I can look at this and I can find my area by doing the same type of thing that we've done before. Since my area is on the bottom, I like to just cross multiply so I can see what's going on. So 123.45 times 360 is going to equal 70 times my area that I'm looking for. And then remember, we want to get area by itself, so I need to undo that with some division. So it's going to be 123.45 times 360. I'm cramming it in here. Divided by 70, and that's my area of my circle. Notice that there's no pi symbol, so they've already kind of done some rounding on this one. So I don't have to worry about a pi symbol right now. So I'm going to put 123.45 times 360 in my calculator, and then I'm going to divide that by 70. And I end up with, since they went 2 decimal places, I'm going to go 2 decimal places. I end up with my area of my circle is 634.8. I better round this up to 9. And it was meters squared. At the bottom, 70. 123.45 times 360. Okay, that was when I kind of set this up. I cross multiplied and then I ended up dividing. Now, here's something that's a little bit different. And when we look at this, we have this circle, we know the area, and we know that, we know how big the circle is, but sometimes they'll ask you what's the radius. So I can use this area. What is that? 634.89 equals pi r squared. And so in my calculator, I know that r squared is going to be 634.89 divided by that pi symbol in the calculator. And then I hope you remember that how to undo something squared, but I would take the square root of that. And would it make sense to get a negative root here? No, not at all, because we're talking about the area. We don't have negative area. So I would really just be looking at the positive root in this one since it's an actual length. And so when we're looking at that, I could type that into my calculator, find this, take the square root of that answer, and I can find what the radius is. So I'm going to do that. I still have it in my calculator here. So divide by pi, and then take the square root of that answer. And my radius is 14.22. Approximately. I had to round. Okay, so that is sector area in a nutshell. I encourage you to try some of the practice because that's really going to see how well do you kind of Can you use the formula and set up the problems? Okay. And if you have questions, let me know. And there we go.